In this video, we're going to look at normal distributions and how can you use the characteristics of normal distributions to make estimates and probability predictions about the population that a data represents. First, we need to know what a normal curve is, and that is the graph of a standard deviation. So let's build the graph of what a standard deviation would look like. First, I put down a number line and my median in place first, and that's going to be marked by an X in the center. To the left and to the right, I'm going to either subtract or add one standard deviation from that median. Farther out, I'll put minus or plus 2 standard deviations and minus or plus 3 standard deviations. One standard deviation to the left or to the right of the median will be 34% on both sides, or 68% in its total. 2 standard deviations in both directions will account for 95% of all of the data points. And 3 standard deviations in both directions, that will account for 99.7% of all of the data points in the data set. Knowing that the center has the most, then to the outside it will increasingly go down. Looking at these percentages, I put in some dots to help me draw a curve of this normal curve. I'm going to connect this line and see that it curves naturally up and back down. This creates a bell shape, so it is often called a bell curve, which is a good keynote to put into your notes. Now, how this data is broken down within the curve is to the left and to the right of the median. While that is 68% of the total of data points, it is 34% to both sides of those data points. Here I'm dividing up my graph using colors to correspond with my writing, and I'm going to fill in my data values. Here I'm going to start filling in the data values onto my normal curve. 34% to each side of my median, 13.5% to the left and right of those respectively, and that's because 95% of the entire set of data is in that area, but remember we've already accounted for 68% in the middle. The next outer regions are going to give me 2.35 into each part to make up the difference to get 99.7%. This is going to leave 3% left over. And the 3% left over is the outermost regions of that bell curve where we have the X plus or minus 3 normal distributions. So that 3% will leave us 0.15, not the 1.5 I started to write, to the outermost regions of both sides. This is what the graph of a normal curve or bell curve looks like. The relative frequency of a data point can be found as the category of data that you're comparing to the total frequency of categories within those data points. As Willy Wonka once said, there is no life I know to compare with pure imagination.